Hi again, this is lesson 10-7, but this is video 2 this time. And now we're going to be looking at the volume of cones. And as you will notice, it is still 1/3 the area of the base times the height, or volume equals 1/3 big B times H. Only this time we're dealing with cones, so the base is a circle. So finding the area of the base is going to be pi r squared, which is why their formula says 1/3 pi r squared times height. So the same overall formula. So now let's get started with it. Let's look at letter A. A cone with a radius 5 centimeters and a height of 12 centimeters. Here we have that I drew, a cone with a radius of 5 and a height of 12. So we're going to say 1/3 the area of the base times the height, or 1/3. Now, our area of our base is going to be pi r squared. R squared is 25, so it's 25 pi times our height of 12. They asked us to leave it in terms of pi and round to the nearest tenth. So first give your answer in terms of pi. This answer is 25 pi times 12 divided by 3, which is 100 pi centimeters cubed, or 314.2 centimeters cubed. I am taping this at the end of a team class, so I'm sorry for the loudness in the hallway. Okay, let's move on to B. A cone with a base circumference, we're going to have to do some backwards work, of 21 pi, you see that right here, and the radius, the height is 3 centimeters less than twice the radius. That simply means 2r minus 3, 2 radius minus 3. All right, so let's work backwards. Circumference equals 21 pi. Pi d equals 21 pi, get rid of the pi, and now we have d equals 21, or the radius equals 10.5. And the height is 2 times 10.5 minus 3. So that is, I think it was 18. Let's see, 2 times this would be 21 minus 3, yes, that's 18. So we have, in our overall formula, 1/3 the area of the circular base, pi r squared, that's 10.5 squared, times the height, which is 18. We do the math on that, leave it in terms of pi, and then change it to our decimal number, that's a tenth. All right, let's move on to example C. Here we have a cone where we are given the radius and we are given the slant height, but we do not know what the actual height of the cone is, so we're going to have to use our Pythagorean theorem. Now remember, you can pause these videos anywhere you need to really study what I've done, but we use the Pythagorean theorem. We found out that the height is 24. Then we plug that in to our formula. Volume equals 1/3 the area of the base times the height. 1/3, here is our 7-foot radius times itself, so that's 49 pi for the area of the base times the height, which is 24. Here it is in terms of pi, multiply it by pi in your calculator, and here it is to the nearest tenth. All right, flip the page. The next thing is something we really just need to talk about. We've talked about this over and over. Exploring the effects of changing dimensions. If we change the dimensions when looking for volume, remember that then we must multiply that same amount cubed by the volume. So if we change the dimensions of this pyramid, each proportionally by 1/4, what are we going to multiply the area by to find the new area of the new figure? We're going to multiply it by 1/4 cubed, or 1/64. Let's look at another one like that. If we take this cone and we double or multiply by 2 the dimensions proportionally, then to find out what the new volume would be, we're going to multiply it by 2 cubed, or 8, not 2 squared. That's only when we're dealing with area and surface area, but when we're dealing with volume, we must cube it. All right, let's go down to the last problem, which is a composite figure, composite 3-dimensional figure, and it's this one right here. And we want to find the volume of it. This is just like the problems that we did in class with pyramids and cylinders. only this time we're adding a cone, or we could be asked to add a pyramid. In this case, we're just going to find the volume of our cylinder like we did in class. Volume equals the area of the base times the height. So we're going to find the area of the circle on the bottom times the height, and therefore we have the volume of the cylinder. Then we're going to move to the cone, and we're going to practice what we were just doing. Volume equals 1/3 the area of the base times the height. Remember, if you found just the area of the base times the height, you would be finding a whole cylinder, but we don't have the whole cylinder. We only have about 1/3 of it in the form of a cone. So we're going to say 1/3 times the area of the circular base, and I'm looking to see what I did there. Give me just a second. I'm not sure I can read that well. Hold on just a second, y'all. Well, I know the answer came out correctly, so I'm trying to, I think that says 12.6. But I think I put that 12.6 in too soon when it's really the volume. So that number must not be correct right there. I think I just jumped ahead. So that should be the area of the base, of the circular base, which would be 4, because the radius squared, pi r squared, or 4 pi. So that's what needs to be inserted there. Sorry about that. All right, then we have found the volume of both. We simply need to add them together, and we have the area of our composite figure. Now let's look at this one. I'm not going to work this one out, but this would be finding, I didn't mean to say the area, I meant to say the volume. I'm trying to go too fast, and I apologize. We found the volume of this composite figure. Okay, now move down to this one. For this one, we would simply find the volume of this rectangular prism. Then we would remove the upside down pyramid. So we would find the volume of the pyramid and subtract it from the volume of the rectangular prism, and that would be it. So I think after having already learned some volume things in class that this lesson is going to be easier for you. But if not, we will be able to talk about questions on Thursday. Hope it goes well.